Hello students, welcome back to today's class on integers, and today we're going to discuss the properties of integers, and in that this is lecture number 2. In the previous lecture in properties of integers we discussed a couple of properties, closure and commutative, and in today's lecture we'll try to discuss about associative and then few other properties and some applications based on all this. Right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So the first one we're going to discuss today is all about associative property. For closure and commutative property, please refer to the lecture number 1 of the same properties of integers. Extension for that we're going to discuss about associative. So what is it? Till now what discussed are with the two numbers A and B, correct? So now let's discuss about the three numbers. Let us extend that to three numbers. So if we have three numbers and we are trying to add or subtract or multiply or divide in different patterns, let's see if those properties can satisfy equal relations. Equal means both sides it should be equal. For example, when we are talking about addition, in associative property, we are taking three numbers A, B, C. And what we are taking here, we are trying to add first two numbers, and to that resulting sum we are adding the third one. And in the other case, add second and third, and to that resulting add the first. Okay. So let us try to confirm whether these two are equal. In the numbers, no, they are equal. You can add in any way, but we'll try to discuss in respect of integers. With respect to integers means again we'll be having positive and negative numbers, so we should be very careful in that. So let us take few examples. So let me take like this: 6 plus 30 plus 5 and 6 plus 30 plus 5. Straightforward positive numbers. All are positive numbers. Okay. 6 plus 30 is 36. 36 plus 5 is 41. 36 plus 5 is 41. 30 plus 5 is again 35, and 6 plus 35 is 41, right? So 41 is equal to 41. So what I can say, when we are talking about positive numbers, all the positive numbers, yes, it is valid. Okay, but let us not try to conclude with this one. Let us also try to take some negative values, but whatever it is, from this I can say that yes, associative property is valid with addition, right? They have associative property relation under addition. But let us not fix it for now. Let us take one more question. Let us try to discuss about that. So what is the next question? Minus 9 plus 11 plus minus 4 and minus 9 plus 11 minus 4. 11 plus minus 4. So the thing is, first we'll try to add these two. Whenever you have brackets, okay, whenever you have brackets, that means that they should be calculated first. That's a group. Only after that you need to go out. Okay. So minus 9 plus 11, 11 minus 2 is 11 minus 9 is 2. 2 plus minus 4, okay, 2 plus minus 4 is nothing but 2 minus 4. Plus into minus, positive and negative will give you negative. So 2 minus 4 is minus 2. 2 minus 4 is minus 2, correct? What about this one? 11 minus 4. First of all, let us try to discuss about 11 minus 4. How much is 11 minus 4? 7. 11 minus 4 is 7. So what we are getting? Minus 9 plus 7. So what is minus 9 plus 7? It is minus 2. So are these two same? Yes, these two are equal. So the numbers may be positive or may be negative. All the integers, numbers can be 0 as well. So for all these, I can say that this property is satisfied. This property is valid. A plus B plus C and A plus B plus C. Add first two and then add the third one. Add the last two and then add the first one. However you add. In addition, the order is not important. It may be natural numbers, whole numbers, integers, or rational numbers. Later we will discuss about that. But in addition, no order is required. You can add in any way. You will get the same answer at the last. Right? So finally we can say that integers are associative under addition. They are associative. Associative means that relation is valid. A plus B plus C is equal to A plus B plus C. Right? Okay. So let us try to discuss the same property with negative. That means with minus, subtraction. And let us try to see if that associative property is valid or not. Okay, so the first one we're having here, a minus b minus c and a minus b minus c. What are we going to do here? We have three numbers a, b, c. We are trying to find the difference of one another. So first we'll try to find a minus b, and then we'll try to find the difference with c, or find b minus c and find the difference with a. So the point is whether these two will be equal or not, that we need to verify. So what is that we can say? Let me try to take the same example with all the negatives. Okay, so minus 9 minus 11 will give you minus 20. Minus 9 minus 11 will give you minus 20, and this minus 2. Minus 20 minus 2 will give you minus 22. Minus 20 minus 2 will give you minus 22. What about this one? 11 minus 2. 11 minus 2 is 9. Okay, minus 9 minus 11 minus 2 is 9. So minus 9 minus 9 becomes minus 18. So now tell me, are these two equal? Are these two equal? No. Why are we getting this difference? Why are these two numbers not the same? Because we have a property, negative into negative is a positive. Negative into negative is positive. So here you can see all these are negatives. That's okay. Minus 9, minus 11, minus 2, we got minus 22. But here minus 9 is correct, minus 11 is correct, but minus of minus 2 will give you plus 2. Minus of minus 2 will give you plus 2, and that is the difference. That is the value. That is the way we are getting minus 22 here and minus 18 here. So we can say that these two are not the same. These two are not the same. A minus b minus c and a minus b minus c. These two are not the same, right? So we can say that integers are not associated under subtraction. Integers are not associated under subtraction. Okay, so you should be very careful. These are not. Okay, so I can say that these two are not equal. A minus b minus c and a minus b minus c, these two are not the same. Okay, so it is confirmed. For subtraction it is not valid. Let us try to see for multiplication and then for division. So the same multiplication also, a into b into c and a into b into c. Let us try to apply that. Okay, so for multiplication let us try to find the product of a and b and then with c, or product of b and c and then with a. Right? So let me take small question. Okay, so minus 9 into 11. 11 nines are 92. So minus 99 into minus 2. Minus 99 into minus 2 is equal to, okay, minus 9 into 11 into minus 2. The first one is 11 into minus 2. 11 2s are 22 with negative. Minus 22. Now, 99 into 2. What is 99 into 2? 99, 9 2s are 18, 9 2s are 18, 119. Okay, so 198, correct? 99 into 2 is 198. So negative into negative is again positive. Negative into negative is positive. So it becomes a plus 198. Plus 198. And this one, 22 into 9. 22 into 9. 9 2s are 18. 9 2s are 18 and 19. Yes, so this is also equal to 198 with negative into negative is again positive. So these two are equal. Not only this one, you can take any numbers, positive, negative, zeros, every number, every integer. So in associative property, multiplication is valid. That means that relation is correct. It is true. We can multiply in any order. Not only in integers, say when you take natural numbers, when you take whole numbers, when you take zero as well, when you take positive, negative, whatever the numbers, multiplication, you can multiply in any order, you will get the same answer at the end. You can multiply in any order, just like the addition. You can add in any order, right, but not subtraction. So what I can conclude here, integers are associative under multiplication. Okay, so that means associative properties are valid for integers. Integers are obeying the property of associative, right? So addition, yes. Subtraction, no. Multiplication, yes. Now let us discuss about division. Same way like this, a divided by b divided by c and a divided by b divided by c, right? So let us try to look into that. So a divided by b, first we need to find the quotient of this one, and with that you need to divide with c. First find b divided by c with that value, a divided by that value, and we need to find whether these two are equal or not. So let me take small question. Minus 12 divided by 3. 12 by 3 is 4, correct? 12 by 3 is 4. So 4 and we have a negative minus 4 divided by 2. Minus 4 divided by 2 will give you minus 2 as the answer. Let us take that here. Minus 12 divided by, this is a 3 by 2. Minus 12 divided by 3 by 2. So what we can conclude? This is equal to minus 12 into this 3 by 2 becomes reciprocal. I told you many times, if we have a fraction in the denominator, that we need to reciprocate. 2 will come numerator, 3 will go to denominator. So 3 ones and 3 6, 3 fours. So this is minus 8. Minus 2 and minus 8, we can see clearly that these two are not equal. And you may ask me one question. Sir, you took some values, it's not satisfied, but I will take another values, A, B, C, such that this is valid. Okay, you can take. You can take, but once for one set of number, if it is not valid, it is not valid throughout. If it is true, it should be true for every case. It should not be like true for specific cases. It should not be false for specific numbers, right? No. If it is true for all. But here you can see that it is not valid. So it is enough to judge or to give the statement that it is not associative. Okay. Integers are not associative under division. Integers are not associative under division, right? So let us try to keep all these 4 at once in associative. Let us try to keep all these 4. Addition we discussed. Yes, it is correct. It is being satisfied. The relation is satisfied. Multiplication correct. Subtraction no, and division also no. These two are not satisfying associative property. And these type of differences will come when you have negative and negative positive in the case of subtraction. And here, when you're dividing the fraction of fraction, so all these are things which will not be satisfied with integers, right? Not only with integers, with any numbers, these two associative property will not be satisfied, right? So let's move forward. Okay, integers are associated under addition and multiplication. For addition and multiplication is correct, but not under subtraction and division. Correct? Right. So let us try to discuss some more properties. The next one we're going to discuss is additive identity. Identity, what do you mean by identity? Simple, let us say your ID card, identity card. What it resembles? It resembles you, right? My ID card resembles myself, my photo and my details. That means if I see ID card, it's about me. My ID card is mine. If you see in the mirror, your identity will be there, right? Identity means the same person. The same number should come again. Correct? The same thing, same. So, if we take a number and if we are additive, that means if we are adding, let me take one number 5, okay, and I want to add some number such that I should again get the same number back, same identity. I should get the same number back, right? So, what I can say here, 0 is the additive identity. Why? You know that 5 plus 0 is equal to 5, correct? Even it is also equal to 0 plus 5. It is a positive number, so you may ask me with the negative numbers. Yes, minus 2 plus 0 is equal to minus 2. It is equal to 0 plus 2. So, 0 plus minus 2. 0 plus minus 2. So, what I can say here, 0 is that number when we add to the given number, we get the same number back. We get the same identity. Identity means the same number appearing again. The same number appearing again. So you can see here, okay, any number, even if you take 0 also, for 0 also, additive identity is 0. So always 0 is the additive identity. Additive identity. 4 plus 0, 4. Minus 4 plus 0, minus 4. Minus 100 plus 0, minus 1000, minus 1 lakh. Whatever number it is, when you add 0, you get the same answer. 0 is nothing, right? 0 has no value. It's not, we cannot say 0 mangoes are there in my basket. That means no basket, no apples, no mangoes, correct? 0 means nothing. So when what you're adding nothing to the number, you will get the same number again. For the number 5, you're adding nothing. So the same number will appear. For minus 1000, you're adding 0. That means you're not changing anything. Same minus 1000 will come. Okay. So that is about additive identity. In the same way, we have additive inverse. You can see here, additive inverse. What will happen with inverse? Inverse means the complete value should change. The complete positive should become negative, so that these two will sum up to give you 0. Okay, see here. For the number A, if you add minus A, okay, additive, you're adding some numbers such that you should get 0. You should get 0. For the number 4, I need to add minus 4 to get the answer 0. 2 minus 2 is 0. 10 minus 10 is 0. Minus 1 lakh plus 1 lakh will give you 0. So that means the negative of the number. The negative of the number is called additive inverse. For a number A, minus A is the additive inverse. For the number minus A is the additive inverse. Understand? If I have 10 minus 10, if I have 20 minus 20, if I have minus 1000, 1000. So these two will sum up to give you 0. A plus some value minus A will give you 0. Right? 20 for number 25, you can say minus 25 is the additive inverse, not identity. Inverse means you should get the sum as 0. You should get the sum as 0, right? 30 plus 0 is 30. Minus 300 plus 0 is plus 300, right? Minus 300 plus 0 is 300, or minus 300 plus 300 will give you 0. So all these are different examples for additive inverse. Simply just change the negative. If you have negative, remove it. If you don't have, keep it. Positive number, you will get negative number. Negative number, you will get positive number. Additive inverse, not identity. Identity means identity should get the same number back. You should not get 0. Inverse means for a positive, you should get negative. For a negative, you should get the positive. Right? That is about additive inverse and additive identity. Next, we will go forward to learn what is a multiplicative identity. The name itself says that. Identity means I said you that we should get the same number back. But in the previous case, it is additive identity where we are adding the number. Here we are multiplying the number. So for a number 10, let us say which number I should multiply. Which number I should multiply so that I can get the same number back, same identity back. Same identity back. So what I can say, for the number 10, I need to multiply with 1. I need to multiply with 1. 10 into 1 is 10. 10 into 1 is 10. 10 into 1 is 10. Only 1, right? You can see here. 1 is a multiplicative identity. For any integer A into 1 and 1 into A will give you the same number A. Minus 10 into 1 or 1 into minus 10 will give you the same number minus 10. Your answer will not change. Your sign will not change. Same number coming again, that is called identity. Here we are multiplying, so we say multiplicative identity. In the previous class we added, there it is additive identity. Right? So you can say that, for example, it's the same kind of example we can take. Minus 256 into 1 or 1 into minus 256, both will give the same answer. Both will give you the same answer, minus 256. Both will give you the same answer, same identity will reflect back. Multiplicative identity. We discussed additive identity, which is 0. Additive inverse, which is for A minus A. Multiplicative identity, which is 1. In the same way, we have next thing called the multiplicative inverse. The next one we say it is a multiplicative inverse. Okay, before that we have additive inverse. I'm so sorry. This is not additive inverse. Okay, this is a multiplicative inverse. This is a multiplicative inverse. That means we are multiplying. Additive inverse we have already discussed. For A it is minus A. For A it is minus A. Here it is for a multiplicative inverse. For the number A, you need to multiply with some number so that you can get 1 back. In additive, it is 0. In multiplicative, it is 1. So for the number 10, you need to multiply with 1 by 10 to get the value 1. So for the number 10, 1 by 10 is the multiplicative identity inverse. Or you can also say reciprocal. The same thing is also called reciprocal. Whatever it is, the product should be 1. Okay. For number 1 by 10, 10 is the reciprocal, or 10 is the multiplicative inverse. Minus 156 into 1 by minus 1 by 56 will give you 1. The same number should come here. Right? For a number A, 1 by A. A can be positive or negative. But we don't say multiplicative inverse for 0. Do you know why? For the number 0, we need to multiply with 1 by 0 to get the value 1. But 1 by 0, is it a defined value? Is it a defined value? No. For 1 by 0 is not a defined value. For multiplicative inverse will not exist for the number 0. Okay, this is very important. Multiplicative inverse will not exist for the number 0. What is a multiplicative inverse? What is a multiplicative inverse or reciprocal of the number 0? You cannot say the answer, you should say undefined. You should give me the answer as undefined, because you don't have the answer, you don't know which answer to keep there. 1 by 0 is not a defined number, right? So you can say that for multiplicative, for number 0, you cannot find multiplicative inverse, right? For rest of every number, for A, 1 by A. For 1 by A, they are reciprocals, or you can say multiplicative inverse, right? So the next we are going to discuss about, only multiplicative inverse of 1 is integer. Multiplicative inverse of 1 is integer. Why? For the number 2, what is multiplicative inverse? 1 by 2. Is it an integer? This is an integer, but this is not integer. For minus 2, minus 1 by 2. But is that an integer? No. But only for the number 1, 1 into 1 by 1 will give you 1. 1 by 1 is equal to 1. You can say that it is again an integer. In integers, only multiplicative inverse of 1 is an integer. The rest of all the integers, you will never get an integer back. Okay. And 0, just now we discussed, 0 does not have a multiplicative inverse. 0 does not have a multiplicative inverse, right? So I think all these are clear to you, right? In the next class, we are going to discuss about distributive property of integers. Okay. Just the way we have discussed the closure. Next, commutative. Let me once again discuss about these two. Okay, so that for a small recap. Today we have discussed about associative, and then we also discussed about additive inverse, additive identity, multiplicative inverse, multiplicative identity. Right? Let me tell you what are closure and commutative just for your reference. Okay. So when we are taking closure property, if you have two numbers A and B, both are being integers. Okay, so we can say that A plus B is also an integer, A minus B is also an integer, A into B is also an integer, A divided by B may or may not be an integer. So closure property is valid for all these except for division. The same way we discussed about commutative property. Do you remember what is commutative? Commutative is again when we have two integers A and B, A plus B and B plus A. Are these two equal? I said in addition you can add in any way. Okay, order does not matter, right? It's correct. A minus B and B minus A, are these two same? No, these two are not the same. So subtraction is not valid for commutative. A into B and B into A, as these two are equal, again for multiplication it is correct, and A divided by B and B divided by A, both are not the same, again for division commutative is not valid, right? So all this we have discussed, and in the coming class we will also discuss about distributive property. Just let me tell you, okay, distributive property. So on this we are going to cover the next lecture, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about the types of motion. Okay. So my name is Seshan Reddy. I'm a graduate from IIT Dhanbad. So let's quickly start the class. So in today's class, basically, we'll be discussing about this translational motion, then rotational, and then oscillatory motion. So these are the three basic classifications, three basic types of motion. What are they? What they represent? We'll be learning about them one by one. So let's go into translational motion first. So what is translational motion? It is if an object moves, look at this, if an object moves in such a way that each point of the object moves the same distance in the same time. What does that mean? This is one example, but you'll understand. Let me explain. If I take a straight road, okay, I'll take a simple example, a very simple example. If I take a straight road, on that straight road, let's say there is a car. Same car here. The same car, okay. So here the car has gone from this position to that position, let's say from A to B. The car is moving from A to B. Okay, now look at this. If the front of the car has traveled a distance of 500 meters. The front of the car has traveled a distance of 500 meters. The question is, how much did the back of the car travel? Yeah. If the front of the car has traveled 500 meters, how much distance did the back of the car travel? Yeah, everyone, how much is that? The same 500 meters, yes or no? It's the same 500 meters. The front of the car is traveling the same distance, the back of the same distance, the middle of the car will also travel the same distance. How much? 500. So these type of motions in which every point of the object travels equal distances in equal time is called as what? Translational motion. Look at the definition again, read that now again. If an object moves in such a way that each point, every point of the object moves the same distance in the same time, those type of motions are called as what? Translatory or translational motion. Simple enough, right? So the best example would be a car traveling on a straight road. A car traveling on a straight road. Okay. Now this translational motion also, we have two types. One is something called as rectilinear motion. The other is curvilinear. Now linear will mean normally line. Rectilinear will say it's motion along straight line. And curvilinear will mean what? Motion along curved line. Motion along a straight line and motion along a curved line. Okay, different types. We'll go into each and every one of them. Rectilinear, it is a case where what? Motion along a straight line is called end of story. Right, and it is a type of translational motion. Because look at this, when you drop a ball, here this being a ball, so when you drop a ball from A to B, then see what happens. The front of the ball, the back of the ball, every point on the ball will travel the same distance. Translational motion. And if the path is a straight line, it is called what? Rectilinear motion. Normally, we also call it as linear motion. Normally, we also call it as what? Linear motion. Simple enough. Then we have curvilinear motion. Simple. Motion along a curved path is called as curvilinear motion. It can be a turn. It can be a cricketer throwing a cricket ball. or it can be us throwing a footballer hitting a football, anything. Okay, curvilinear motion, motion along a curved path. It is also a type of translational motion. Simple example. If I take a curve here, and let's say there is a car moving on the road. Okay, the car has come from there to here. Now here again the same thing. If the front of the car has traveled 500 meters, then the back of the car, sorry, that's not the front, and not until here, just a minute. If the front of the car has traveled how much distance? 500 meters, then the back of the car will also travel how much distance? 500 meters. In fact, every point of the car will travel how much distance? 500 meters. Translational motion. Yes or no? That's what translational motion will mean. Clear? Every point of the car should travel translate the same distance. Simple. So curvilinear is also a type of a translational motion. Okay. Now simple. What is that? The following is undergoing curvilinear motion. Curvilinear. Options. Coin moving on a carom board. Carom coins. Cyclist taking a turn on the road. Object dropped from a height. Or all of the above. Which of them is curvilinear motion? Everyone, what is that going to be? The answer is what? The answer is the cyclist taking a turn on a road. Now we just discussed it. Car on a turn. So in place of a car, if you have a cycle, it is a turn, a curve. Curvilinear. On a carom board, when you hit a coin, coin goes along a straight line. Coin doesn't curve. Coin goes along a straight line. Yes? Same thing. Object dropped from a height. If you drop an object, the object goes down along a straight line. Object dropped from a height. So these two are wrong. Those two are rectilinear. B is correct. Clear? Okay. So that's what? Translational. Now there is a special case of curvilinear, a special case of translational. What is that? That is circular motion. What does that mean? You can clearly see a circle here. If the object moves on a circle along a circular path, it is called as circular motion. The special case of curvilinear or a special case of translational motion. Clear? So motion of a body along a circular path. And in a circular path, what happens? See here. What is specialty of a circle? There is a center. I'll just draw it here. If this is a circle, if this is a circle, imagine it as a circle, then every circle has a point center. Now from any point on the circle, here to center, here to center, here to center, all these distances are equal. If this is 2 centimeter, this will be 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 2 centimeter, this will also be 2 centimeter. The distance of any point on the circle to the center will be equal. See here. That is what? That is the property of a circle. Going in a circular path, that means what? That means distance of the body remains constant from a fixed point. From which point, everyone? From the center. Center of circle. See? 2 centimeter, 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 2 centimeter. Clear? The distance from the center remains constant when the object circular path. Clear? That is circular motion. You can clearly see a circle traveling along a circular path. Circular motion. Clear? Okay. Now that is circular motion. And it is also a type of translation. Circular motion is also a special case of what? Translational motion. Clear? Okay. Now interesting case which is rotational motion. Now there might be fans in your rooms, right? If you look at the fan, then you can clearly see something like this. This is a table fan. Same principle, right? So here the blades of the fan rotate. And this type of motion is called as rotational motion. Now what is the speciality of rotational motion? On that itself will be the difference between rotational and circular. What is that? Here at the center in the table fan, this fixed. So if you imagine a line passing through center in this way, that complete line will be as what? Fixed axis. Look at this. Think of it as a globe. That in fact is Earth rotating about its own axis. But yeah, we can get a globe in our hands. So if you take a globe can be rotated. Now there will be a line here. If you have a globe, you can notice it. That particular line, that support will be fixed. So that line will be called as the fixed axis. Because it does not move. It does not move. Even in a fan, like a ceiling fan, the blades rotate, but at the center, no rotation, it will be fixed. The center will be fixed. Clear? Yes. Okay, so that's what we talk about when we talk about rotational motion. Motion about a fixed axis. If you have a fixed axis, it is rotational motion or rotatory motion. Clear? Okay, we have many such examples for rotational motion, but always you have to look for the fixed axis. When you get the fixed axis, it means it is rotational motion. Okay. Okay, next. So let's go into a simple question. Is rotational motion a kind of translational motion? Is rotational motion a kind of translational motion? What do you think? Yes or no? Think about it. Is rotational motion a kind of translational motion? The answer is no. Why? Like I said, look at this. If this, you can do it now itself. Take your hand, any hand, left, right, doesn't matter. Keep it in this way. Just lift it. It's like you're lifting something. You're doing bodybuilding. Okay? Do it in this. Now the elbow is fixed. Your elbow is not moving. Wherever the elbow is, that is fixed. You are just raising your hand. Right? Now look at the fingers. These fingers are coming from here to here. See how much the fingers are moving. But if I look at the other part here in between my hand, that is moving a least distance. Lesser than the fingers. How? You see the diagram? In the diagram you will easily understand. Here is the elbow. Our elbow is fixed. This part is for the fingers. See how much distance the fingers have moved. The fingers have moved this much distance. But whereas if I look at this here, this point here, the middle point, see, look at the curve. The middle, a lesser distance. Yes or no? You can take another part here. A, B, I'll take another point here, C. Fingers, the point A, the point B, the point C, all of them are moving different distances. They are not traveling equal distances, they are moving different distances, and if the points move different distances, that is not translational. Right, here I can clearly say the fingers A and fingers point and then points A, B and C move different distances. Move unequal distances. So it is not translatory motion, not translational motion. That is rotational, by the way. Okay, we are rotating our hand. Clear? The same will work when you door or close a door. That is also rotational. Opening a door or closing a door is rotational, but it is not translational. You can note there also. Okay. So is rotational motion a kind of translational motion? The answer is no. Okay, explanation is here. Understood? Now the difference between rotational and circular, very interesting topic. Okay, rotational and circular are different. Rotational motion, it is rotation about a fixed axis, there is fixed, a point which is fixed. But in circular, it is motion along a curved path, along a circular path. Mostly not a curve speaking, a circular. Simple, the complete body will be moving. It is not a type of translational motion, but circular motion is a special type of curvilinear motion which is translatory. Now for examples of rotational motion, a spinning top, and a door which is being opened or closed, rotation of earth, rotation of fan. For circular motion, you have athlete running on circular path, a car moving on a circular path, a stone going along a circular path, all of them. Clear? So this is very important, very interesting topic, difference between rotational and circular. You have to understand that. There are many examples where you can watch and visualize and imagine. So please do that. Okay. Now we learn translational. We learned about rotational. Then we learn about oscillatory motion. What is that? Very simple one. It is the to and fro motion of an object. Just understand this. This is the key words, points for oscillatory motion. To and fro motion of an object. Now you can see here, what is this? This is a swing. Now what's happening in a swing? The boy is coming forward, going back, again coming forward, again going back. It repeats. Right? So here I can say that, I just say this is point A, this is point B. So he is going to B. He's going to B and from B. Going to B, coming back from B. Going to B, coming back from B. Going to B, coming back from B. It takes place. Yes or no? Even when we play on a swing, the same thing happens. So it's to and from B. To and, let's write it down here. To and from B. So here which motion is this? To and fro. Fro will refer to from, that's it. Don't write it as from, write it as fro. Fro is a keyboard. So to and fro. Fro, what does fro mean? Fro will mean from. So it's a to and from motion. To and fro motion. What is that called? Oscillatory motion. What is that called as? It's the name. Remember the name, everyone. Oscillatory motion. So to of an object about a top, it will be fixed. About a fixed point, always following the same path. Same path. Yes or no? He is called as what? He is called oscillatory motion. Simple. This here, so you can say the examples. Boy on a swing, a girl on a swing, anyone. And here we have a simple example. Here we have a thread and we have a mass. We call it as a bob, and this setup is called as simple pendulum. Is one of the classic examples, of oscillatory motion. A pendulum. Clear? Okay, that's good. Chalo. So we learned about different types of motion, the translatory motion, the rotational motion, and the oscillatory motion. Okay, thank you, thanks a lot.